Today, this video would show how you can recall waveforms previously generated on the VXG and with the PXA using the power amplifier test. So I have the waveforms previously generated on Signal Studio, and that would be the 5GNR FR1 100 MHz wide signal. So now under the PXA, let's turn on power amplifier. And we will just keep it at a normal view. It has detected that triggering is set to channel 1, so let me just do a little refresher here. You would have to connect the 10 MHz out signal from VXG to the external reference in of the PXA or UXA if you're using a UXA. And we're setting up for channel 1 synced out of the VXG to trigger 1 in of the PXA here. Because my signal is set 1 GHz, I'll keep it as that. Oh, perhaps we'll look at FR2 signals, so the reference would be at 25. I'll keep that at 25 GHz. So let's go to measurement setup and get a few things going. As you can see, it's currently not connected to the VXG. It says here disconnected, so there'll be a few setups. Let's go ahead and preset the radio standard. So we're looking at FR2, 50 MHz. Okay, signal generator wise, let's go to connection management. I have previously connected to the IP address, so the LAN ports needs to be connected too. Let's just hit that. So this would be the Signal Studio where you would generate the signal, export the waveform file, and also save the settings file, just so that it would be easier to recall some of these files. So that's the right IP address, so I'll connect to it. It's turned green, so I'll hit close. Reference signal. This is where you'll locate a predefined waveform file. As I've mentioned, I have created the signal before, so I'll go ahead and select it. So just a quick note here for FR2, just remember to make sure the phase compensation is turned off. That might be a little too complex for the power amplifier measurement. I can now see a signal has been generated, and it looks like it's set to 50 megahertz wide, which is great. So it might take a little while, and that's completely normal. Once that's loaded, we can then go ahead and set up our amplifier in the test. The next step would be to go to the amplifier tab. You want to input a maximum power level that the amplifier can sustain. If you have attenuations connected before and after the amplifier, you would factor that in with loss into the amplifier and loss out at the output of the amplifier. So for example, if I have 5 dB attenuation in and out, I would update it here. I would also then update the gain of the amplifier in the test. I currently do not have an amplifier, so I'll just keep this as 0 dB because I only have a direct connection. And we would control based on the output power instead of the input. So we'll just keep this to minus 10 dB. If you want to do a control, you can turn power servo on with say a tolerance of 0.1, and that should bring it as close to 10 dBm as possible. If there are no errors, then we're good to go. So again, with FR2, it might take a little while, and that's completely normal. So now we'll open another tab to look into the modulation analysis. Let's bring up the 5GNR modulation analysis tab with normal view, and that should be good. So we have a output power now that's set to 10.04. It might take a little time here for it to load. Just bear with that as the program is loaded. So you will see that it's a sync error, and that's completely normal. So first of all, again, let's just go through the setting. We'll set the carrier frequency first, and that's at 25 gigahertz, and immediately you could see some signals. It says ADCO range, so I would want to just turn on attenuation, sync error. So triggering is not free run. As I've mentioned, you would have connected channel 1 synced out of VXG to trigger 1 in of the PXA, so external triggering 1. For simplicity's sake, let's do a recall of the setup file, which I have previously saved under PA mode file. So you would have to browse to the folder where you have the waveform saved. And that would be the file that I'm after. Let's do a recall. With that, you would immediately have the EVM, and the triggering of the subframe would be auto-generated. So let's just go to measurement setup, measure time, and you can see this is populated. This is clean. You can just do an auto scale here to zoom this in, and EVM is at 0.93. So we could go back to settings and do an optimize. And it's gone down to about 0.8. So now that we can go back to the power amplifier app and turn on the EVM measurement. So now that that's populated, EVM measurements do not turn on, so we would go to PA measurement, EVM. Now if this is too small, or too large, sorry, you could go to settings, user interface, and control size too small. This would be limited to your screen size. You might not have a problem if you're in UXA, but in PXA you might need to change this. So let's turn on EVM. Let's close that and let it run. So you can see that it's now populated and EVM is at 0.76, so we had an optimization earlier, and that looks about right. If you like to turn on the DPD model, you could go ahead and do that. Although based on this plot here, you might not have much improvements, in fact, because it's pretty much in the linear region. But if you have an amplifier in the test, you'll be able to adjust the power levels to just about to hit compression or the non-linearity region, and that would create a much accurate DPD model. But just to show how you can go ahead and do that, I'll just turn on the DPD, memory polynomial model. So this is the DPD model. As you can see, it's just provided a slight improvement. That's how you can apply DPD. So if you would need to do a extraction, you can turn that on. You could go into the configuration and do a couple of settings here. So if we want to, you can go ahead and save either the states, the measurement data, the DPD results. So this is where you're able to pull out the data type, whether it's the DPD model, the PA model, or the pre-distorted waveform. You could also do a capture of the screen image. And if you happen to have a Skippy recorder, you could Skippy commands listed, you could save that as well. That's all we have for today. Thanks for watching.